remember the product law of exponents? What's x to the power m times x to the power n? You're supposed to add them, right? Yes? Okay, so I'm gonna prove to you what this is equal to. So as you can see on your formula sheet, this is equal to log of m base a plus log of n base a. Very similar, right? If you're multiplying the same base of an exponent, you add the powers. Here, if you have a product of a logarithm argument, you can separate them by adding. So let log of m base a equal x, and log of n base a equal y. So I'm going to change this into exponential form. So can anybody do that for me? Can you change this one into exponential form? Yeah, so then a to the power x equals m, and what would this become? A to the power y equals n. So now I'm going to actually multiply a to the power x times a to the power y. Do you see that would be m times n? Yes? Look what I did. I took a to the power x, and that's m, and a to the power y. Oh, that should be an a, sorry. Yeah. Oh, sorry. A to the power y is n, and so that becomes the two multiplied together. Everybody agree? Okay, so I'm actually going to simplify this. I don't know why there's an extra dot there, but anyways, I'm going to simplify this side. So does everybody see that using those exponent laws from before, that this is the same as mn? So now what I'm going to do is I'm going to change it back to logarithm form. So I'm going to keep that together, of course, keep that together. So now let's switch it back to logarithm form. So what would that be equal to? X plus y is going to be log of mn base a. And what is x plus y equal? Those two added up, right? So I'm running out of room. So that would be log of m base a plus log of n base a would be this together. So although this is the proof, how do you actually do this? Well, we're going to do, say, for instance, this following example, and we would be doing this without a calculator. So you have to actually use the exponent theorems, the logarithm theorems to actually do this. So if we have an addition of two logs that have the same base, we can put it together as, so if we have two logarithms with the same base and it's adding, we could put it together as multiplying. So that would mean this is 100 times a quarter. Does everybody agree? That's how I'm applying that theorem. And what's 100 times a quarter? 25. So this would be log of 25 base 5, and hopefully by now everybody knows what that's equal to. It's equal to 2. So normally you wouldn't be able to do this without a calculator because the logarithms are, you can't find 5 to the power what is 100 or 5 to the power what is a quarter. But if you actually use the logarithms, you can actually evaluate and get a nice number. Okay, moving on, the quotient law. What was the quotient law of exponents? Yeah, you subtract it, so you get x to the power m minus n. Does everybody agree? So same thing goes here. If you have a logarithm of a quotient, you can separate it by writing it as individual. The one on top is the positive one. The one on the bottom is the negative one. So again, I can do the same proof. Let x equal log of m base a and y be log of n base a. And this time I'm going to change it, well, not this time. Again, I'm going to change it into exponential form. So what would this become as an exponential? A to the power x equals m, and this would become a to the power y equals n. Yes? Now I'm going to divide. So I'm going to have a to the power x divided by a to the power y. And that's the same thing as m divided by n. Everybody agree? Okay, and that would simplify to be a to the power x minus y. Yes? So again, I'm going to keep this together. I'm going to keep this together, and I'm going to switch it back to logarithm form. So what's my log equal to? Well, x minus y is equal to the log of m divided by n base a. Yes? And again, if I plug in what x equals, that would be log of m base a subtract log of n base a, and that's what my theorem actually equals. So again, although we could do the following example separately, let's use the log theorems to do it, and then do it separately. We could do it the other way around. We can do it separately, then together. What's log of 64 base 2? That would be 6. What's log of 2 base 2? 1, and 6 minus 1 is 5. So now this time I'm going to actually use the log theorem. If it's subtraction, I can put this together as what divided by what? 64 divided by 2. Does everybody agree? Subtraction becomes division when you put it together. So what's 64 divided by 2? 32. And what is log of 32 base 2? 5. Do you see I get the same exact answer? Okay, next one. This one is the power law for logarithms. And what it says is this exponent of a logarithm can be written in as a product in front. So log of m base a. So basically that little power exponent can be moved. So let x equal log of m base a. Is everybody good with that? Okay, and then we're going to put this into logarithm form. So what does it become? A to the power x equals m. Is everybody good with that? So just like I can square both sides, or square root both sides, or fifth power both sides, I'm going to n power both sides. So if I n power, I'm going to write it in a separate step. So a to the power x to the power n equals m to the power n. Does everybody see that? Yes? So what do I get when I do that? I get a to the power xn equals m to the power n. Does everybody agree? Okay, so this time I'm actually going to, this will be my exponent, right? And this will be what the argument is. So I'm going to keep xn as my exponent for my logarithm. So that's what it's going to equal. Does everybody see? I should have put it in alphabetical order, but it doesn't matter. So now switch this back to logarithm form. So do you see this exponent, xn? I'm going to write it as nx equals the log of m to the power n base a. Does everybody agree? And so, of course, remember back there I said what x is, so that means n times log of m base a is equal to log of m to the power a. So it just basically shows that this n can be written in front like that. So again, I guess I didn't do the power law up here. That would be multiply the two together, yes? Okay, so again, I don't have a calculator, so I'm going to do these logarithms without a calculator. So the problem is 49 to the power of 5 is a huge number, right? But if I use my log theorem law that says the 5 can be just written in front, this becomes 5 times log of 49 base 7. Does everybody see that I can do that by applying those laws? Okay, so what's log of 49 base 7? So this is just 5 times 2, which gives me 10. Easy, right? Okay. So now we're going to practice writing as a single log. This has consequences later down because we're going to be solving log equations later. So we have to be able to rewrite expanded logs into single logs. Okay, so example 1 says write as a single log. And so the first thing is you cannot do this unless it has the same base. So that's why the A was the continuous base in my theorems there. So the first thing you should do is start by turning any coefficients into, so for instance, this is a coefficient of a log. What would I turn that into? Huh? Exponent, yeah. So I'm going to do that. So this would be log of x squared minus log of y minus log of z. Okay. Positive laws go into the, what am I looking for? Numerator. And negative logs go into the denominator. So all negative logs are going to go into the denominator. All positive logs are going to go into the numerator. And whatever's on top, we're going to multiply together. So that means this would be log of what? Again, positive goes on top. Negative goes on the bottom. So x squared would go on top. Everybody agree? And then the y and the z will go to the bottom. And if you look at that going the other way, does that make sense to you? If it's dividing the y and the x, that both of them would be negative going the other way, right? Okay, why don't you, is that enough? Can you do B and C by yourself? No, I'll do B one more time. Okay, so this is, we need to write as a single log, right? So they already have the exponents essentially there and the second one. But the third one doesn't have the exponent where it should be, right? So first step, write as the coefficients would be in front. Or sorry, the in front coefficients would be as a power. So this would be log of y squared. Does everybody agree? Everybody see that the logs are all base 7? So now I can write it as 1 base 7 log. What goes on top? Well, that's a cube root, sorry. So that would be the cube root of x would go on top. The y cubed would go on the bottom. And the y squared would go where? On the top, because it's actually positive. Remember, we could have wrote this in a different order. So does everybody see the y squared would be like that? Okay, we can actually simplify y squared over y cubed. And we get as our final answer, what? Yeah, the cube root of x over y. Very good. Okay, I want you to try C here. Might be 2 marks. Anyways, I'll show my steps here. So this is log of x squared minus log of y cubed minus log of the 4th root of z plus log of w. Oh, geez. I guess I'm going to write it as the power 2/3 because that's a z, not a 2. Okay, so then it's log of x squared, y cubed is on the bottom. The z, if you want, sorry. I'm going to write the z on the bottom as, you can write it as z to the power 1/4 or the 4th root of it, and then w to the power 2/3. Okay, is everybody good? Questions? Okay, continue. Now we're going to expand these, so anything that's on a numerator would then be positive, yes. So this would be A, positive, yes. So we're going to add C. Now C is to the power what? So that means really there's a 1/2 in front here. I'm skipping a step. Subtract log of B, and where does that 2 go? As a coefficient right there. So there's my final answer. This is why it's only 1 mark, because you can do this in 1 step, right? Once you get to what it is. Okay, so I'll give you a second to do B. Do B. Okay, 2 log A plus 2 log B minus 1/2 log C minus 1/2 log D. Bam! Everybody get that? Okay, let's move on. Okay, so this would be log of 32 times 2. At some point, I'm not going to show my steps anymore. That's just log of 64 base 4, which is 3. Addition becomes multiply, then log of 64 base 4 is just 3. So minus is going to become 108 divided by 4, yes. So then, what is that equal to? 4 goes into 10, 27. So what's log of 27 base 3? Okay, moving on. The next one's try yourself now. Yep. Did anybody get F in their assignment there? A question like that? What does that equal to? That was something I told you to memorize?
Yeah. Okay.
So what is it? Yeah, it's equal to 3. Okay, these are all the same base. So log base 10 of 4 times 5 divided by 2. So that is log of 10 base 10, which is uno. Yes? So this is log of 12 squared divided by 4 squared. Now, you could square 12 squared and 4 squared. Did you know you could also divide 12 divided by 4, then square it? Which would be way easier if you don't have a calculator. Does everybody see that you could? That's like a property that, like exponents, you can separate the fraction, right? So this is the same thing as 12 divided by 4, the whole thing squared. Would you agree that the squaring goes to both the top and the bottom? And of course, 12 divided by 4 is 3. 3 squared is 9. So this is log of 9 base 3, which is 2. But you could have went 144 divided by 16, but I just think it's harder to divide a 2-digit number there. Same with this one. If you write this together, this is this 175 over 7, and if you want, it's the whole square root, right? So if you actually divide that first and then square root it, probably easier. So what would that be? 7 goes into 17 twice. 25, sorry. 25, that doesn't look like a 25. 25, so what's the square root of 25? 5, so then log of 5 base 5 is 1. And we already talked about F. Okay, all that grade 10 stuff to come back at you, because really D, this and the square root thing you learned in grade 10. Actually, even grade 9, I think. But now that you've seen it again, you'll remember to do stuff like that. Okay, so here is a provincial exam question they've given in the past. And it is on the calculator side of things because it's got decimals in there, all that. Okay, so it says we don't know what the base is. But it says find the value to 2 decimal places. I don't know why it's 2 decimal places, but it doesn't matter, of that. So, and you'll have some of these in your homework tonight as well. And what you have to do is you need to expand the logarithm and rewrite 10's. Well, 3 is already there, but you got to write 10 as 5 times 2. Do you see that? Yes? So do you see that this would be the same thing as log of the square root of 10 base a subtract log the square root of 10, sorry, the square root of 3. Try that again. The square root of 3. Is everybody good with that? Did everybody see what I did? Again, going back to grade 9 or 10, we learned that the square root of 10 over 3 is the same thing as the square root of 10 over the square root of 3. Yes? I should have an A. And then all I did was I separated that as subtraction. So now I'm going to rewrite the square root of 10 as the square root of 5 times 2. Does everybody see that? So then this would be log of the square root of 5 base a plus log of square root of 2 base a subtract the log of square root of 3 base a. Is everybody good with that? The square root is not what the logarithms are, so I need to get rid of that square root by doing what? The only thing I can with logarithms is move it to the front. So this is 1/2 log of 5 base a plus 1/2 log of 2 base a minus 1/2 log of 3 base a. Some of you could probably go to that step in the first step. Okay, we're not done yet. So now we're going to actually find the value. Does everybody see here that this is that? And this is that. And this part is that. Yes? So now I'm just going to sub it in. You could factor out the 1/2 if you wanted. It's up to you. It's a 1/2 to both. I was going to do that, but I didn't want to confuse anybody. So 1/2 times 0.8271 plus 1/2 times 0.3562 minus 1/2 times 0.5646, and then I'm going to grab my calculator. It's probably easier if you did factor out the 1/2 and you don't have so much to deal with, but it's all good. Did you get that as your answer? 0.30935. Yeah? Okay, questions how I got that. Essentially, I just expanded it. The biggest mistake I see students make on this question is they actually square root this number instead of half it, right? I'm trying to think of another thing that you could make a... Anyways, so the B question says find the value of A to the whole number. So does anybody think they know what A could be? A is the base of the log, by the way. So what could it be? How would I figure that out? I do have a calculator. Yeah, I can use this, or I can use any of these ones here because they're all the same A, right? So yeah, you can have A to the power 0.3562 equals 2. And then how would I solve what A is? How do I solve what A is if A is the power 0.3562? Yeah, you can do the root of so it's the 0.3562 root of 2. The other way is if you don't have that on your calculator, I don't know if it'll let you do decimals actually as that x root. Like how would you get a to a to the power 1 there? You'd power root it of what? What would you do to both sides? Power root both sides to 1 over 0.3562, right? Whatever you do to one side, you do the other. That's Algebra 101. Yeah, so 2 to the power 1 over 0.3562. Oops, I didn't do 2 to the power. I'll try that again. 2 to the power 1 divided by 0.3562. So you get roughly about 7.000274, blah, blah, blah. So that means A is approximately 7. Now you could have guessed and checked because it's going to the nearest whole number. I saw some people do that when they asked this on the provincial exam. But algebraically, this is how you solve something like this, right? Does that make sense to you that that's how you'd solve it? Because, well, how would you cancel 0.3562? You know what I mean? It's like saying, if I have a to the power 3, how would I get to a to the power 1? I would 1/3 power both sides to get 1, right? So if this is 0.3 blah, 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 then I'm going to be 1 over 0.3 blah, blah, blah to get the 1, right? Okay, next question. Again, they asked this in one of the provincial exams. So how would we solve this? Well, there's a bunch of unknowns here. We can do some log theorem rules. What does subtraction of the same base mean? I can divide, so this is the log of x of 27 divided by 3. Again, you don't have to show this step, just divide 27 divided by 3. And then what do you get on this side if you have a coefficient of 2 right there? Yeah, this would be y squared with a base x, yeah. So I'll write this again. This is log of 9 base x equals log of y squared base x. So at some point you realize that if they have a log of x like this, kind of like if the bases of the exponents are the same, that means the exponents are equal. You know what I mean when we were rewriting the same bases? Does everybody see if you have logs with the same bases, that means these have to be the same, right? That means y squared has to equal 9, or y equals plus or minus 3. However, you can't have a negative 3, so I would reject it. And does anybody know why? Does anybody know why? You can't have not negative exponents, but you can't have negative arguments there, right? So you might argue, well, there's a square there, so it'd be positive. But originally, it was 2 times whatever you get here. And if this y was negative to begin with, it would be undefined. And you can't square an undefined value, right? So it would be done from the very beginning.